today I'm going to talk to you about graphs of the gradient of a function. So let's just begin by looking at a function for a start. Let's have a look at this kind of function. This is some kind of polynomial, but what we can see is its gradient is continually increasing. It starts off very positive. It gets a little bit more gradually positive, but it continues to be positive all the way up. This is a positive gradient. Let's just have a look at a negative gradient. Graphs that are going down are going, as you read from left to right, the gradient or the graph is going down. It has a negative gradient. So all the way along here, we have a negative gradient. And you get quadratics. Let's look at a quadratic graph. There are various quadratics. Let's look at a positive quadratic. Positive quadratic, well, the gradient begins negative. Negative, gets slightly less negative till it reaches this turning point here, where for a moment the gradient stops being negative and is not positive, it's zero. Then the gradient turns around and it becomes positive. So being able to identify the gradient at every single point along the graph allows us to be able to draw what we call a gradient graph. The gradient graph describes the derivative of the function of the curve that you drew in the first place. So I'm going to look at this particular one here. Let's have a go at drawing the gradient graph for this particular one. Let's give these some figures here. Let's call the intersection here 2. The turning point, let's call it, -2. Let's call this turning point -1, -2, and that's all really we need to know. Now, if I draw the gradient graph, I'll have x along the bottom, but along the y-axis will be dy dx. All right, so dy dx. All right, so I'm going to look here, and we'll see that when x is negative, so this is x along here, when x is negative, the gradient is negative. This is the gradient here, so somewhere down here, it's negative. And it's negative till it reaches 0, which is when x is -1. So when x is -1, the gradient here is 0. And of course, this is my gradient, so it's going to be, and of course, don't forget, when we differentiate a quadratic, we go down a power of x, so our gradient function will be described as a linear relationship. So we know that this is going to form a linear straight line. So as I get to there, now when I get to there, what happens here is now the gradient becomes positive, okay? And it doesn't necessarily matter where it cuts the y-axis, but what we do know is that after x is -1, the gradient becomes positive, and it gets more and more positive up to here. And that basically is what we call a gradient graph. All right, so on the board I've got a graph, and this is a function, some function f of x, and here's the x-axis. Let's just talk about the gradient at each point on this graph that we can see. So this gradient is negative, 0, positive, all the way up to 0, and then back negative. Now, as this is f of x, if we differentiate this function, we get the gradient function, which is f dash of x. And what we want to do is look at, well, where on this graph, for what values of x is f dash of x, or the gradient, below 0? Here, below 0. When is the gradient f dash of x above 0? This one, greater than 0. And when is f dash of x, or the gradient, equal to 0? So obviously we can see on the graph now we've put the signs of the gradient where each of those occurs. So what we're going to do is write down the values of x that apply for each of these. So when the gradient is greater than 0, that means it's positive. So it's positive from x is -1, but it's not including -1 because at -1, the gradient is 0. So x has to be greater than -1, but of course it's positive up until 5, but it's not including 5 because at 5, the gradient is 0. So of course this works for when x is greater than -1, but less than 5. When is f dash of x less than 0? Well, less than 0 is everywhere where the gradient is negative. So we can't include -1 in our domain here because, of course, -1 gives the gradient of 0, and we can't include 5, but we know we want to go -1 less than -1 towards negative infinity because the arrow indicates that it continues. And of course, we want to say x greater than 5 towards infinity for when it's less than 0. And then when it's equal to 0, we'll be writing for when x equals -1 and for when x equals 5. Okay, so just finishing that one off, then I'll write for x is less than -1 and x is greater than 5. All right, that's pretty much everything you need to know about gradient graphs, just general basics. Obviously, if you want to look at gradients of other functions such as sine and cosine, then you'll need to look into my Unit 3 and Unit 4 videos. Thank you.